So now let's talk a bit about the limitations of HTTP and about another protocol that can kind of fill in the gaps of HTTP, which is WebSockets. But there's also a lot of application layer protocols. We're not going to be talking too much about all of these because I don't think it's super important, but you've almost certainly heard of some of these. FTP is file transfer protocol. By default, it runs on port 21. As the name implies, it's for, transferring large files between computers. There's SMTP, which stands for Secure Mail Transfer Protocol. It runs on port 25, I believe, by default. These ports, by the way, aren't super important. I'm just kind of mentioning it because we know HTTP by default runs on port 80. The rest of these also have their own default ports. But SMTP is, optimized for sending emails. SSH is to remotely connect to another machine and run, a CLI on that machine. WebRTC is for video and audio streaming. The interesting thing is that all of these are actually built on TCP. Reliability is important for these protocols. WebRTC, though, since it's optimized for video and audio streaming, this is actually built on UDP. So TCP is definitely the more common transport layer protocol, but UDP also has its use cases. It's all about the trade-offs. And now we'll be moving on to the trade-offs of WebSockets and the differences with it between HTTP. So let's first look at the problem that we're trying to solve. Let's say that we are trying to build a chat application. So right now I'm on Twitch. We're just watching some random streamer, and here we have the chat. So you can see that users are typing, their messages. Doesn't really matter what they are. There's some text. Each user is able to send messages in the chat. And of course, we are seeing messages in real time. As the messages come in, we are seeing them from all of these users. So how would we implement this? So from our browser, as the client, we can send requests and we get responses back. With HTTP, we can load twitch.tv, we can load the web page, we can load the list of streamers, we can get a lot of information. HTTP is satisfactory for pretty much everything we need to do. But when it comes to reading chat, how are we going to do it with HTTP? At time, let's say 12 p.m., we could send an HTTP request and get a list of all the chat messages at that time. Now, maybe at 12:01 p.m., we could send another message and then get all the messages at that point in time that were sent, in between 12 and 12:01. We could keep sending HTTP requests like this to update us with all the newest chat messages. This is called polling. This can be implemented with HTTP, but the problem is, how do we time these intervals? Probably 1 minute is too long to wait. That means we'd have to wait 60 seconds before seeing the newest messages. Maybe we can poll every 1 second. That would probably be good enough. And this would probably work in most cases with HTTP, but it's less optimized. You can see this way, us as clients, we have to create a new connection, a new HTTP connection, which we know is built on top of TCP, which is somewhat expensive. And we have to create a new connection every time we want, the newest chat messages. A better way to solve this problem is with a better protocol. Better in terms of that protocol is designed to solve this problem. It's called WebSockets. What we first do is called the WebSocket handshake, which basically the client will actually send an HTTP request, and that request is to establish a WebSocket connection. So after that HTTP request, the server will usually respond with a status code of 101, which basically means it's taking this connection and upgrading it to a WebSocket connection. So that's the WebSocket handshake. Not super important to memorize. But the important thing is that after that handshake, there is a persistent connection established between the client and the server. So there is a connection. It's not like HTTP, where with HTTP, we send a request, get a response back, send another request, get another response back. That's kind of how it is with HTTP. But with WebSockets, there's just a connection established and we can send information in both directions. With HTTP, usually the client initiates some request and then the server responds with what the client needs. With WebSockets, the client is the one initiating the connection, but once the connection is established, data can move in either direction. Like we could send from the client, like maybe as a user, I'm typing a message, that message goes to the server. Maybe I send another message and, a third message. 3 messages were sent. The server didn't have to respond with anything, but then maybe I don't type anything for a few minutes and then the server starts responding, every time there's a new message. Like some other user on the other side of the the world is typing in, some ABC message. And every time that happens, the server is going to push that information to the client. As the client, we don't have to poll. We don't have to keep checking. Does it have a new message? We don't have to do that. Every time there's a new message, we immediately receive that from the server. The server pushes that information to us. And, we could also, as users, send information to the server at the same time that that's happening. It's not a big deal. So this is bi-directional communication. This is something that HTTP doesn't really do out of the box. Well, at least not until HTTP version 2, which introduced streaming, which kind of makes WebSockets obsolete, actually. But to avoid confusing you, we won't go super in-depth into that because WebSockets are very prevalent to this day. And most people, I assume, don't even know that HTTP 2 actually makes WebSockets obsolete. So I think in a real interview, WebSockets are perfectly fine. I would just feel irresponsible if I didn't kind of mention this caveat. But now going back to our Twitch example, and I'm going to go ahead and open up the network tab again and refresh so that we, get our data here. So this is a bit hard to read, but what I'm going to do over here is in the filter window over here, I'm going to type in WS for WebSockets. And here you can see that we have a connection right here. This is the name. It's the chat for our Twitch streamer that we're watching here. This is the chat connection. And guess what? Which protocol is it using? Not HTTP. It's using WebSocket because this is kind of exactly the problem WebSockets is for real-time chat communication. So here you can see it responded with a status of 101. That is from the initial HTTP request that was made to twitch.tv with a GET request to establish that WebSocket connection. And it responded with a status of 101. It was switching protocols. It's upgrading this to be a WebSocket connection. And then after that's done, we can go to the messages tab here. And here you can see the actual interesting stuff. We can, scroll through here and get the messages in real time. Every time we get a new message, this is some metadata. I think it's which user did this message come from. But if we scroll all the way, eventually we get here. This is the message that somebody typed in. Let's just go to the most updated one real quick so that we can find it in the chat here. Somebody is saying, what is the number in the middle of Zarya's? I'm just going to copy that, make this window a little bit more readable. I'm going to Control F and see, yep, this is the message that somebody just typed. We got it in our WebSocket connection. The benefit of this is we don't have to make a request to the server every few seconds, for example, to check, was there a new message? Anytime there's a new message, we are immediately pushed that in real time. Every time we type a message here, other users are seeing that in real time. This is less expensive from a networking perspective. We don't have to create a new connection every single time. We just have to do that WebSocket handshake. We establish a connection. We can send data in both directions. So now if you're designing an application that needs some kind of real-time data streaming or bi-directional communication, aka a full duplex connection, that basically means we can send data both directions, WebSockets is what you would use. So this is really, really useful for creating any type of chatting or real-time data, like something like a live feed, like your Twitter feed, for example. That could be implemented with polling. Like if you check every few seconds, is there a new tweet? That would be perfectly fine to implement with polling. But for something like Twitch chat, we probably don't want to use polling. If we have hundreds of messages coming in a minute, we want to see those messages in real time. The order of those messages might also matter. So WebSockets is better for that. The downside is that there is a state established between the client and the server. Maybe this connection could actually break at some point and then the server would continue to send data. But in general, what we covered, the problems that WebSockets solve is what you should really be focusing on. The conceptual difference between, the client initiating every request, receiving a single response for every request, whereas WebSockets, we can, just keep communicating in both directions.